In this video, I'm going to show you how to use differentials to come up with a local linear approximation simply by using everything you already know about finding the equation of a line. So if we look at our function, again we have 2 points on the actual function. One of them is x comma f of x, the other one is x plus h comma f of x plus h. These would be these corresponding points here. And then we have a tangent line at that point, x comma f of x. And if we are looking at x values that are close enough together, whatever that means for a particular problem, but they need to be close, then what we'll see is that this tangent line actually approximates the function pretty well between x and x plus h. So that means that we could actually use the equation of this tangent line, which ultimately we're going to find is just y equals some mx plus b. And we'll be able to plug in any x value we want to approximate the y value for on the function, plug it into this equation, and it will approximate the y values that are up here as long as we're in between x and x plus h. So this is called a local linear approximation because, of course, you see we're doing it locally, only in a very small area in the function. And we're turning whatever the function is into a line, so it's a linear approximation, hence the name. So I've drawn the points in here, and so what we use the equation of the tangent line to approximate the functional values between x, f of x, and x plus h, f of x plus h. So we're just saying here again that we're going to use this tangent line to approximate those functional values. All right, so what do we need to find the equation of a line? Well, we need the slope, and we need some point. Well, if we know that this is a tangent line, I think we know that the slope is a derivative. We also are given points, right? We know the point x comma f of x. That needs to be a given point. We'll also see that that needs to be a point that we actually know what the functional value is. So we have to find some point close to this x plus h, some x value close to that when I plug it in the function I can actually evaluate it because I need to actually have this point. And if that's the case, you see here that I know that m is f prime of x. And then I know the point on the function, and it's shared by the line, x comma f of x. If I know the point and I know the slope, I can find the equation of the line. So let's take this example. We're asked to approximate e to the minus 0.1. So I've got my graph here just so I have some idea of what it looks like. And I know that the closest x to x equals, and that's really minus, get that in there, minus 0.1. That's going to be x equals 0 because I can actually evaluate e to the x when x is equal to 0. So I have to pick the closest one that I can actually plug in the function and I know the functional value without using any calculator. So I know that e to the 0 is 1. So that means that I have a point on my function and a point on my tangent line that I know, and I can also find the slope. So we're going to use the equation of a line for this approximation as we said before. So here we have our picture again. We know that the slope of that tangent line, the blue line, is f prime of x. We're going to find out what the slope is when x equals 0. So f prime of x is e to the x, and e to the 0 is 1. So the slope of my tangent line is 1. I also know that when x equals 0, then the functional value, e to the x, is e to the 0, and that gives me 1. So now I know that the slope of my tangent line is 1, and that a point on my tangent line is 0, 1. So I'm going to use y equals mx plus b. You can use any of the formulas for finding the equation of a line where you have a point and a slope that you like, because we know that m is equal to 1, and we know that we have a point on our line which is 0, 1. All I'm doing here is finding out what b is. B equals 1, so the equation of my line is y equals x plus 1. So this means for x values in that interval between minus 0.1 and 0, y equals x plus 1 approximates y equals e to the x. So I want to know what happens when x is equal to 0.1. I plug that into the equation of the line, so I have minus 0.1 plus 1, which is 0.9. So this tells me that y equals e to the minus 0.1 is approximately 0.9. And if you use your calculator to actually approximate that, your calculator will give back that e to the minus 0.1 is approximately equal to 0.90483. So our approximation is actually good to 2 decimal places.